Hello, everyone. I hope you're doing well. This is the video showing some examples for chapter 3. So let's get started. Give me 1 second, please. And I'm going to do a couple of exercises from each one of the 3 sections of chapter 3. Let me share my screen with you. Okay, so this is section 3.1. This section deals with measures of center, and we know that that's a way of describing the whole data set with only one value. Let's try to find that one value that represents the whole data set. And we learned a couple of different ones. So on number 5, we need to find mean, median, mode, mid-range, and then answer a question. These are amounts in dollars it costs for marriage proposal packages at different sports venues. Are there any outliers? So what we're going to do is we're going to go to StatCrunch. Please. And on StatCrunch, we can go to data. Stat. We go to stat, summary stats, and we go to columns. And then we select the column we want. And here, we select the statistics we want to find. There are many options. I always like selecting all of them. Just to do this only once. But if you want to do this several times and selecting the one you need, you can also do that. So this is all we need to do. We select what column, we select what statistics, and then we click on compute. And here are the values that we need to input in the problem. So let's just start with the mean. The mean is 380.52. And we know we need to round it to 2 decimal places. Very good. Then we find the median. We have it here, median 200. Again, round it to 2 decimal places. In this case, it's an integer, so we leave it as is. Is there mode? This one is simpler to check by ourselves, like with our naked eye. We can just tell if there's a value that appears more than all the others. But StatCrunch also does this for us. So we can take a look here. The mode is 475. So there is a mode, which is $475. And the mid-range, we cannot find with StatCrunch, but we can just calculate it ourselves. If you don't remember the formula, let me quickly go back to the slides for section 3.1. We see it right here. The mid-range is the average between the minimum and the maximum. So let's go back to our DataCrunch results. Here we can see what the maximum and minimum are. So we have 39 and 3,000. We want to add those two together. And then we divide by 2, which gives us, I'm going to go back to the problem, 1,519.5. Remember, I got this from doing 39 plus 3,000 over 2. Because that's the minimum plus the maximum over 2. Perfect. And then, are there any outliers? What do we think? B is the right answer. Remember, there is a way to know if a number is an outlier, because we talked about this in section 3.3. An outlier is a value that is far away from the others, but how far away is far away, right? So we quantify that But in general, we can tell that all these numbers are very similar to each other, and the last two are the ones that are very far away from them. If the numbers were closer, we can do the procedure we do in section 3.3. Okay, good. Let's take a look at question number 9. So here we need to find the mean, and this is another special case we found here. This is for a frequency distribution. We have an example on slide number 5. And remember, what we do is we have a formula. We're going to calculate a quotient. The numerator is the sum of the products of each class midpoint by its frequency, and we divide by the frequency. Let me show you really quickly so you know what I'm talking about. Is this formula right here. Numerator is the sum of the class midpoint by each frequency, and we divide that by the total amount of data values, which is the sum of the frequencies. So let's do that. I'm gonna close this, and remember, the class midpoint is the midpoint between the lower class and the upper class limits. So we just add them together and divide by 2. So the first one is 42 times the frequency plus the next midpoint for the second class, which is 47 times frequency. And we can keep finding this midpoint by doing the average of these two, or we can also just keep adding the class width. So we know the second one is 52 times 13 plus 57 times 4 plus 62 times 2. And we divide by the sum of the frequencies, like this. So let's find this value with our calculators. And we actually have to do it this way. We cannot find this using StatCoach. So the numerator is 1,399 over 27. That is 51.8, because we're rounding to the nearest tenth. I hope this is clear. Remember, if you have any questions, this is not clear enough, please reach out, let me know, and I'll try to help via email, or we can also schedule a tutoring appointment or office hours. So that's number 9. There's another question. Compare the computed mean to the actual mean of 52 degrees. So we're comparing these two, 51.8 to 52.2. It's pretty close, 0.4 difference. The computed mean is close to the actual mean because the difference between the means is less than 5% of the actual mean. The difference is 0.4, right? And how much is that with respect to the actual mean? Is 0.007, so that means 0.8%. So no, option A looks good. And yeah, so these 4 options are just asking us, is the difference between these two less than 5% or not? So for them to be close, we need them to be less than 5%. Okay, good. And let's do one last one. Question number 12. This is a weighted mean, which is like a generalization of the frequency distribution mean. The formula is very similar. Let me show it to you really quickly. It's basically the same formula we use for the weighted mean. We only change the W's those W's were F's before. That's the only difference, right? So basically, a frequency distribution is a weighted mean, but where the weights are the frequencies. And this exercise 12 from this homework assignment is just very similar to this example on the slides. So let's try to work through it. So I think it's actually not that similar. Oh, but this one is very useful, I think, for a student, because like in all of our classes, we have like certain percentages for assignments and midterms and all that. So you would like to know how to do this, to know like what grades you need for a test or stuff like that. So let's take a look at the instructions. A student's course grade is based on one midterm that counts as 10% of his final grade, one class project that counts as 20% of his final grade, a set of homework assignments that counts as 50% of his final grade, and a final exam that counts as 20% of his final grade. His midterm score is 60, his project score is 94, the homework score is 75, the final exam score is 67. What is his overall final score? So let's do that first. We know it's a quotient, and we want to multiply each weight by its X value, and then we add them together. So for the one midterm, that is 10%, I'm going to represent that as a decimal. We multiply it by its X value, which is 60. In this case, the X value is the score they got in that midterm. The next class is the project. That is worth 20%. We multiply that by the score. His project score is 94. And then a set of homework assignments, which is 50%. And the score is 75. And lastly, we have a final exam, which times the score of 67. And we divide by the sum of the weights. In this case, we know it's a percentage. We can do it just to check, but we should get 100% as that sum, which in this case, as a decimal, is equal to 1. So let's try to find this. 0.1 times 60 plus 0.2 times 94 plus 0.5 times 75 plus 0.2 times 67. 75.7 over 1. So that is the final score. Type an integer or a decimal, do not round. Got it. And then what is his letter grade? They are then telling us that mean of 90 or above is an A, 80 or above is a B. So on. So 70, between 70 and 80, it should be a C. We got it. So this is section 3.1. We're just finding a lot of different measures of center. I hope this is clear. So we're going to close this. And then we're going to go to 3.2. Review. Section 3.2 deals with measures of variation. And this basically represents how spread out the data values are. Are they all close together? Are they very spread out? So these three measures of variation we learn, range, standard deviation, and variation, are telling us that. So for this one, let's do number 7. Listed below are numbers of hurricanes that occur in each year in a certain region. The data are listed in order by year. Find the range, variance, and standard deviation for the given sample data. Include appropriate units in the results. What important feature of the data is not revealed by any of the measures of variation? So again, I think we can definitely calculate these three by hand. We're using our calculators. The standard deviation is particularly long, so we're going to do it with StatCrunch. So we go to the StatCrunch website, and we do what we did before. We go to stats, summary stats, columns. In this case, let's get the variance and standard deviation. Let's go to range. We compute, so we have them right here. So we start with the range. We see that the range is 19. We can also find these ourselves by subtracting the maximum data value minus the minimum data value. And remember that the range has the same unit as the data values. Standard deviation, we're gonna take the result from StatCrunch. So let's go back there. Standard deviation is 6.513. Let's take a look how many decimals we need to one decimal place. So we round this to 6.5. 6.5 hurricanes. Standard deviation uses the same units as well. And for the variance, once we have the standard deviation, we could square it, or we could also take this result from StatCrunch. Here the variance is 42.4. And remember, the variance has units squared. So there we go. And then they ask us what important feature of the data is not revealed through the different measures of variation. The measures of variation reveal nothing about how the numbers of hurricanes are spread. It's false. That's exactly what they do. Option B, the measures of variation reveal no information about the scale of the data. That's false because we have units. Option C, the measures of variation reveal nothing about the pattern over time. This might be the one. Because even though we have a data set ordered by year, we don't see any pattern just by looking at these results. And then we can check that option D is also false. The measures of variation do not reveal the difference between the largest number and the smallest number, which is false because that is exactly the range. So they do reveal that difference. Good. So whenever we need to find these, we can just use StatCrunch. Okay, let's go to question 11. The body temperatures of a group of healthy adults have a bell-shaped distribution with a mean of 98.19 degrees Fahrenheit and a standard deviation of 0.42 degrees Fahrenheit. Using the empirical rule, find each approximate percentage below. So let's take a look at the empirical rule really quickly, just so that we are on the same page. This is the empirical rule for data with a bell-shaped distribution. We know that 68% of the data values are within one standard deviation from the mean. 95% are within two standard deviations from the mean. And 99.7% of the data are within three standard deviations of the mean. We were given the mean and the standard deviation. So let's see what the questions are. Part A, what is the approximate percentage of healthy adults with body temperatures within three standard deviations of the mean? Just saw that is 99.7 by our empirical rule for data with a bell-shaped distribution. This is slide number 9, the notes. And then part B, what is the approximate percentage of healthy adults with body temperatures between 97.35 and 99.03? So this is basically the same, but they are not telling us what is the difference in standard deviations. So we need to find that ourselves. So what we're going to do is we're going to take the mean, which is 98.19. We subtract the minimum of these values, 97.35. And that difference is that is the difference between two values. And if we divide by the standard deviation, we will get how many standard deviations away from the mean this value is. So we do 98.19 minus 97.35. That is 0.84. And we divide by 0.42, which is 2. So this means that these two values are 2 standard deviations away from the mean. And by our empirical rule for data with a bell-shaped distribution, if we are 2 standard deviations away from the mean, that means that we have 95% of the data values within those two numbers in that interval. So the answer here is 95%. And that's it. If we had gotten 1 standard deviation as our result, that would be 68. If we had 3 again, that's part A, right? So 99.7. Good. So let's now go to section 3.1. I mean 3.3. We have a couple. On this first part, we're dealing with z-scores. So let's try question number 12. For a data set of the pulse rates, for example, of adult females, the lowest pulse rate is 35 beats per minute. The mean of the listed pulse rates is x bar equals 75.0 beats per minute. And their standard deviation is s equals 22.4 beats per minute. Part A, what is the difference between the pulse rate of 35 beats per minute and the mean pulse rate of the females? So this is just a difference. 35 minus 75. Wait, we have to actually subtract it. Sorry about that. So yeah, I missed the step. That is 35 minus 75, but we actually find that number. The difference is how many standard deviations. So we need to divide now. We have this difference. We divide by the standard deviation. So we know how many standard deviations there are here. We then round to 2 decimal places. So this is 1.79. And then we find the z-score. Remember the z-score? We have the formula x minus the mean over the standard deviation. In this case, the mean, the value is 35. The mean is 75, and the standard deviation is 22.4. Notice this is precisely what we calculated above. So these two numbers should match. Good. And the lowest pulse rate is, okay, we are in part D now. If we consider pulse rates that convert to z-scores between -2 and 2 to be neither significantly low nor significantly high, is the pulse rate of 35 beats per minute significant? So they are just telling us it's going to be significantly low if it is below -2. So that's not the case. It's significantly high if it's above 2. That is not the case. So it is not significant. Okay. Oh, I mean, you can like rewind and pause if you want to take a look at that again. Sorry, we missed that word. We lost that, but that's what we do, and that's basically a z-score. We're just trying to change the scale with what we're measuring. Let me show you this image I really like. We're trying to go from this mean of mu and standard deviation of sigma, and we're trying to standardize it. So we have a mean of 0 and a standard deviation of 1. Okay. Now let's take a look at question 17. Use z-scores to compare the given values. This is another, this is a way we can use z-scores. If we have two different data sets measured in different units or that measure different things, if we standardize both of those results, we can finally compare them. So that's what we're going to try to do in this problem. Let's take a look. Based on sample data, newborn males have weights with a mean of 3,207.3 grams and a standard deviation of 928.9 grams. Newborn females have weights with a mean of 3,092.4 grams and a standard deviation of 606.8 grams. Who has the weight that is more extreme relative to the group from which they came? A male who weighs 1,500 grams or a female who weighs 1,500 grams. So we first find the z-scores for both of these, and then we compare them. Remember the formula for the z-score, x value minus the mean over the standard deviation. So in this case, for the male, the x value is 1,500. We subtract the mean, which in this case is 3,207.3. And then we divide by the standard deviation of 928.9. This will give us a result of -1.84. We usually round to 2 decimal places for z-scores. And we're going to be using z-scores a lot, chapter 6 onwards. So remember that rule. We always round to 2 decimal places. Now let's find the z-score for the female. We have 1,500, that is the x value. We subtract the mean, which is 3,092.4, and divide by the standard deviation. So we calculate this. We get -2.62. And notice the z-score that is farthest away from 0 is the one for the female. So that is the one that is more extreme relative to the group. So the female has the weight that is more extreme. Okay, I hope this is clear. And lastly, let's take a look at question number 20. Here we are trying to find percentiles. So in a data set with a range of 55.4 to 105.4 and 400 observations, there are 276 observations with values less than 86. Find the percentile for 86. So remember, the percentile for this number is what percentage of data values are below that one. So in this case, we have 276 observations below the value 86. So to find that proportion, we take the 276 and we divide by the total, which is 400. So if we do that, we get 69. So that is the percentile. What we're saying with this is 69% of all the data values are below 86. And that is the definition of percentile 69. That is the percentile of 86. Good. So this is the first part of section 3.3. This is all the first 5 slides, and then it starts. Well, no, it's also quantiles. We did that as well. And then I think from slide 10 to 16, that is part 2. So let's do one example from that one. 3.3 part 2 preview. Let's try to do number 2. Following are the ratings of men by women in an experiment involving speed dating. Use the given data to construct a box plot and identify the 5-number summary. So remember, the 5-number summary is, we have it right here. Minimum, first quartile, median, third quartile, and the maximum. And we can easily find all of these with StatCrunch. So let's do that. We open in StatCrunch. We go to stat, summary stats, columns. We select the variable. And I'm gonna select all of this just because that is my preference. But we don't need all of this. We only need those 5 that I mentioned. So we start with the minimum, 2. Then we need the first quartile, which is right here, Q1, 3.5. Then the median, which is 4. Then the third quartile, which is 5. And finally, the maximum, which is 8. So those are the numbers for the 5-number summary. And then we need to select the box plot that best represents this 5-number summary. So let's take a look. Remember, the little box starts at the first quartile and ends at the third quartile. So we want a box that starts at 3.5 and ends at 5, which should be C. And that's it. Oh, we lost it again. But yeah, that's basically it. I think we did a little bit of everything. If this is still not clear, please let me know. Please reach out. I will be happy to help. And we can find some other means of trying to solve all your questions. Okay. I think that's it. Let me stop sharing and stop recording. It's all season.